In this video, uh, we will continue answering questions related to potential and kinetic energy. So let me rewrite three important formulas. So for PE, potential energy is equal to the mass times the gravity times the height. For kinetic energy, it is equal to 1/2 times the mass times the velocity raised to 2 or to or squared. Yeah. For TME, the total mechanical energy, it is equal to the sum of PE and KE. And another thing is, actually, it's supposed to be 4. Total mechanical energy before is equal to the total mechanical energy after. So basically, the concept of TME, it supports the law of conservation of energy, which states that energy cannot be created nor destroyed. It can only be transformed into another type. So what we mean by that in this equation is that the total mechanical energy from before is the same value after. It can be in a different form of energy, but nevertheless, that energy is not destroyed or created. So yeah, for this, uh, we have a new formula. It's the formula for power. Power is the unit is in watts. For work, we always know that it is in joules. Um, Although yes, it could also be Newton meters, but this is more associated with torque. Now, for time, as usual, it's in seconds. So, power is equal to work over time. So, yeah. Right now, it's best that you start memorizing the formula. It's gonna come in handy. So, yeah, let's start with number 1. So, you do 45 joules of work. So, work is equal to 45 joules. 30 seconds, time is equal to 3s. In the previous video, I stated that for work, I would always abbreviate it with the word itself, work, for the sake of not confusing the symbol W with weight. But here in this scenario, I don't think weight is going to be mentioned. So yeah, we do have mass, but I don't think weight is going to be involved in any of our solutions. So yeah, let's just understand that work is W in this video. Besides, we're not going to use weight anyways. I just said it. Okay, how much power do you use? We have the work, we have the time. P is equal to W over T. So, P is equal to 45 joules divided by 3 seconds. And P is equal to 15 joules per second, by the way, can be written as watts. Now, I think we have a new problem. Watts is abbreviated with capital W, which is also the same for work and weight. So, let's just write the entire unit, like literally watts, just to prevent any confusion. But if you're solving on your own, then yeah, as long as you understand what you're writing, feel free to take conventional shortcuts as much as possible to be efficient. Okay, for number 2, hang on, let me just write it here. Joules per second is the same as watts. Okay, number 2, the car uses 2,500 joules, so this is our work. The time that we have is 25 seconds. Power, or just P, is missing. So, simple. We use this formula again. So I believe this is going to cancel out. We're going to have 100 as an answer. Okay, next, number 3. Okay, so a 60 watt light bulb runs for 5 seconds. So the time is equal to 5s. The watt value, that's for power. So what's being asked is the energy. In this case, what are we supposed to do? I believe energy is associated with work. I mean, what else could it be? Could it possibly be with respect to the relevant context? So P is equal to W over T. W, therefore, is equal to P times T. So, sorry about that. 60 watts times 5 seconds. 60 times 5, that is 300. 300, what's the unit for work? So, as stated earlier, watts is the same as joules per second. And what we have at the other side, 5 seconds. The second unit will cancel out and we have joules instead. So 5 times 3 is 15, 1,500 joules. That is our answer. Is it? Sorry, where did 300 come from? I wonder. Anyways, minor mistake. Actually, I can say it's minor since if I didn't notice it, it could jeopardize the entire solution. And it's gonna constitute a wrong answer, and that's what it takes to get a full deduction. So yes, at least we found it. So 300, 100, and 15 watts. Okay. Number 4, the mass is 2 kilograms. The total height is 100 meters. On another planet, gravitational acceleration. So definitely, in this scenario, the setting is not on Earth. It's in a different planet, and the gravity is equal to 8.0, which is basically 8 meters per second squared. So, PE, KE, time, and power are required for each. So, let's start with this first. The first row. So, we have 100 meters. So, H is equal to 100 m. Let's look for PE first. PE is mgh, 2 kg. I don't have to convert this anymore since kg is an SI unit that corresponds to the mass. And that is the unit for mass in this scenario, the desired unit. Gravity is 9 point, no. It's custom. It's 8 this time. Okay. And the height is 100 meters. PE is equal to 2 times 8 times 100. It is equal to 1,600 joules. So that is for this one. How about kinetic energy? So we know that the total distance is 100, right? And what we're given in the present in the current row that we are at is 100 also. So the total minus what we're given is equal to 0 meters. So this is the distance that we'll be using to find KE. So KE, we don't use this, okay? So KE is equal to 1 half mv raised to 2. What is the mass? 2 kilograms. What is the velocity? We don't know it. So how do we find velocity? We cannot use this formula, I think, since we don't have enough data for the PE plus KE that all corresponds to before. We only have one known value so far. So we take the kinematic method. We use kinematic formulas to find velocity. First, we start with looking for the time. T is equal to 2d over g. Is it? I'm pretty sure that's the formula. T is equal to 2 times, what's the distance? 0 meters. So yes, regardless of the other values, since we have a 0, 2 times 0 is 0, 0 divided by 8 is 0, 0 square root of 0 is 0. So we have the time immediately. Let's look for the velocity using this kinematic formula. So Vi, as stated in the previous video, will always be equal to 0. It's an implied given. Since it's stated the rock was dropped. So it was not stated that the person forcefully threw the rock downwards. It was only dropped. So the velocity at the initial velocity is supposed to be 0. And the maximum velocity is supposed to be Vf, like right before it hits the ground. So yes, Vi is going to be 0, therefore we have this instead. Vf is therefore equal to Gt. We know that T is equal to 0, so this is 0. Meters, sorry, is it? Yeah, meters per second. So that is our Vf. Now let's look for Ke. 1 half times 2 kilograms times the velocity of 0 meters per second. By the way, these are the same, Vf and V. So always make sure that in the Ke formula, the V here isn't Vi, it's Vf rather. It's more sensible if you think about it more closely. So Ke is equal to 0. Since anything multiplied to 0 is 0, this is our answer for Ke. 0 meters per second. Okay, so first, hang on. Kilogram times meters per second. I think that's joules. Sheesh, I almost screwed up in that part. Yeah, also the squared. I always forget that. Yeah, always remember in the Ke formula, don't forget the squared. I remember just now I've made multiple mistakes because of that minor detail that I missed. Anyways, so yes, it makes sense. Meter squared times second squared times kilogram, that is equivalent to joules. Let's move to the second row, such that the height is 75 meters. Sorry, wait, no, we're not done yet. We ought to look for the time, right? Actually, we do have the time already. In fact, we found it earlier, and I didn't even know it was intended to be discovered as a final answer. But now because of that, we place a brown box. Now we look for the power. P is equal to W over T. Power is equal to, what's the work? Where do we find the work? I think we need to look for the weight. I have a feeling. Let's try this. So our mass is 2 kilograms, right? So weight is equal to mg. So for the sake of not confusing W, possibly suggesting work or weight, I'll just write the entire word itself. So mass is 2 kilograms. The gravity is 8 meters per second squared. So this is Newton. 16 newtons. Hang on, why do we need to look for the weight in the first place? Since work is equal to FD or WD. Makes sense. So 60 newtons times the distance. What is our distance? 0 meters. We don't use this. This one is only used when finding for PE. But this one is going to be used for finding everything else, such as the K, particularly the KE and the work, and possibly even impulse and momentum. But I'm not sure about that. So far, we're sure that KE and work, they utilize this distance. So 0 meters. Yeah, the work is equal to 0 joules. So 0 joules over 0 seconds. Power is equal to 0 watts. That is the answer for power. I did not expect that we would be involving weight in this kind of problem. Anyways, next question, the next row. D is, or the height is 75. Let's look for PE. PE is 2 kilograms times 8 meters per second squared times the height, which is 75 meters. PE is equal to 2 times 8 times 75, that is 1,200. So kilogram times meter squared over second squared, that is joules? Is it joules? I think it is, yes. Yeah, energy is measured in joules. Next, let's look for the KE. So we can find KE using two ways. Since we are given, since we know two values, one for potential and another for kinetic energy. And we also know the potential energy in this row, which is 1,200. You can look for this one using the TME before TME after formula. So I'm thinking you might, it would be useful, it would be timely to use it now. Sure, yeah, let's give it a try. So TME, let's just write before, is equal to TME after. So TME before consists of KE before and PE before. And for the other side, it's basically the same thing, but with after. So KE plus PE before, that is 1,600 plus. By the way, why did I write meters per second there? That's wrong. Anyways. Sorry, KE is what we're looking for. But PE after is this one. Let's look for that. Let's write it down here. There you go. So transpose 1200 to the other side. Our answer is this. Okay, now that we have the KE, let's try solving the other way, using kinematics, just to prove that KE can be solved using two ways, and you're just not limited to one method or one approach. To give you some to give you a luxury of breathing better when trying to solve. Okay, let's start with kinematics. Let's look for the time. T is equal to 2D over G. T is what? Hang on. Before that, again, the total is 100 meters. We subtract, we put 75 here. It's going to equal to 25 meters. So this is the distance that we will be using for KE and power. So for finding KE and power, D is 25. Gravitational acceleration is 8. 50. So square root 50 over 8. 2.5 seconds. Such a clean number. Next. What are we looking for again? Okay, yeah. VF. Or just simply like that. So VF is equal to 8 meters per second squared times the time, which is 2.5 seconds. So it's equal to 20 meters per second. So this is cancelled out. We have meters per second squared left. Okay, so far so good. VF, now we use the KE formula. 1/2 times the mass, which is 2 kilograms, times the velocity, which is 20 meters per second, and then we put squared. KE is equal to 1/2 times 2 times 20 raised to 2. 400. Exactly the same value that we had earlier. So they're the same. So this is method 1, this is method 2. Either way, just make sure you know the process and yeah, have fun solving. We have, what else do we have to look for? Time. Time, we already found time, right? Yeah, in this scenario, we have to look for time. So it is suggested that you use the kinematics approach. Using the TME before equal to TME after, you won't be able to find the time. So yeah, the method is effective, but you still have to look for time. Use the kinematics to save time, like literal time. .5 seconds is right there. Power. Let's look for power. Jeez, we don't have much space anymore. Again, actually it's still the same, right? The weight is still the same value, regardless of the distance. So 16 newtons. Work is equal to FD or WD. This is so weird. Just write work. 16 newtons times distance. What's our distance? 25 meters. 400 joules or Newton meters. So 400 joules divided by the time. Our time is what? 2.5 seconds. Joules per second is, in other words, watts. 400 divided by 2.5 is equal to 160. Okay, so far so bueno. Is it? Yeah. My answer key affirms that we're on the right track. Next, we have 50 meters. We have 50 meters, and yeah, let's start looking for the PE. Dang, this is kind of long. Still a long way to go. But yeah, after this, it's going to be the end of the video. Next video will be about momentum and impulse. Everything that I've learned, everything I've mastered for the exam. The Grand Imperial exam. Mass, again, mass is 2. Is it 2? I forgot. Yeah, 2 kilograms. Gravity is 9.8 meters per second squared. Height is 50. 2 times 9.8 times 50. 980 joules. Okay, so again, our total is 100 meters. And we minus 50. It's going to be 50. It's not a coincidence that these two are the same. Just so happened. It's not a coincidence, and it's important to know that. Now, let's look for KE, shall we? Let's use the kinematics approach. K is equal to 1/2 times 2 kilograms times V raised to 2. Let's look for the time. T is equal to 2D over G. Okay, so square root of 100 over 9.8. That is 3.19438 seconds. What's next? Yeah. Use this. VF is equal to 8 meters per second squared times 3.19438 seconds. Okay, 25.55506. Sorry, that's not the final answer yet. Was I just in a trance for a while? It's kind of weird. Okay, the answer is 653.0610916. Let's just leave it at this. Are we in the right tracks? This is a weird number. This is a really weird number. Okay, something's wrong with the time. Yes. I see the mistake. Why did I use Earth's gravity? We're given a custom gravity in the first place, so Yeah, that's the mistake. Sorry about that. Square root of 100 over 8. Now we're getting it. Okay, so the VF therefore is equal to 28.28427 meters per second. So if we use that here, 1/2 times 2 times 28.28427 raised to 2. Alright, now we have an answer that's more like it. 799.99993 joules. I swear I wasn't writing meters per second. Anyways, this is roughly 800 joules. Let's just write 800. Peace of mind. So 3.53553. 3.53553 seconds. Potential and kinetic are both 800. Yeah, mistake here also. 2 times 8 times 50. 800. Okay. We have to look for the power. Work is equal to W times D. Distance is what? 50 meters. 800. Newton meters or joules? So, power is equal to 800 joules over the time. Time is what? 3.53553 seconds. Two 226.27442. Power is in what? What is power? Ah, yes, watts. I had a mind block back there. Okay, 25 meters. PE is equal to 2 kg times 8 times 25. 400. Distance for solving for KE and power is 75. Kinematics. Just to let you know, in your journey in practicing these kinds of questions in physics, you will eventually feel that G will always be 9.8. But try to avoid carelessness in that aspect. What I did earlier, it hasn't been a stranger to me. It's been a force of habit. So yeah, try to avoid making that mistake. Okay, now we have the time. By the way, did I box the time in the previous questions? I mean, in the previous solutions? I did not. Okay, so far so good. KE. We have to find VF first. VF is equal to G times T. So this is our VF. Why does this phone keep ringing? Sorry about that. That's the third time, I think. Okay, now let's look for KE. Okay, we have 1200.00165 meters per second. Or just basically 1200 joules. Okay, work is equal to W times D, the weight times the distance. Weight is 16 newtons, distance is 75 meters. So it's 1200 joules. You put it there. Okay, time is what? 4.33013 seconds. So power is equal to 277.127938, or just 9394. And then watts. Okay, so that's the answer for power. Okay, we're on to the last row. Distance is 0 meters. So PE is equal to 2 kilograms times 9.8 meters per second squared times the height, which is 0 meters. So obviously PE is 0. Okay, total is 100 meters, and then minus what's given right now, which is 0. it's 100 meters. Again, not a coincidence with the total. It just so happens that the given distance is 0 meters. And that's what we use for potential energy. But this one is used for finding KE and power. I'm saying it again and again so that, yeah, I don't think there's anything bad with that. It helps you memorize to the point that it's annoying. D is what? 100 meters. Okay. Time is 5 seconds. GT is equal to VF. Let's cut to the chase. G is what? 8 meters per second squared. Time is 5 seconds. 40. KE is equal to 1/2 times mass 2 kilograms times 40 meters per second. Don't forget the square root. Sorry, the raised to 2. So what does the calculator say? 1,600 joules. Okay, 0, 1,605. Let's look for power. That's the last thing. So again, work, which is this, is equal to weight times distance. Weight is 16 newtons, as stated earlier. Distance is 100 meters. So 100 times 16, I think that's 1,600. Is it? Yeah, it is. So power is equal to 1,600 joules. Time is 5 seconds. 1,600 divided by 5, that is 320. And then we put watts. Okay, we're done. Okay, what did we do so far? So yes, that's all the solution for number 4. And yeah, the rest are easy. Yeah, that's it for this video. Thanks for watching. Next video will be about impulse and momentum.